warned me that this was a well-read group, but I had no idea how well. So I have designed this talk for what I would present to our first and second year nutrition students, because I find that a lot of the information in here they don't have, even though they're well-read. So bear with me if you know it already, but I think I can usually, pick up something. What I want to start out with is reminding you that combustion in a flame is the same chemistry as respiration in the human body. In each case, you're using some fuel, you're combining it with oxygen to produce CO2 and water. Same thing happens as we breathe. And there are the similarities. Using a fuel, combining it with oxygen, producing carbon dioxide and water, that releases chemical energy. The energy in the bonds, the carbon and largely the carbon-hydrogen bonds. And ultimately produces heat in the flame and in the body. The human body and the mammalian bodies, of course, use a different fuel. They largely run on free fatty acids, glucose, and a little bit your amino acids. They produce heat during those chemical reactions, but as we've talked about a little bit today, there's a coupling, metabolic coupling that goes on that uses some of that chemical energy, about 40%, to produce ATP. And it's that ATP that runs the rest of our body. We can measure energy metabolism a number of different ways. The way it's usually done now is to use indirect calorimetry, and what that means is that the measurement of heat production, which is calorimetry, is done indirectly. Not by measuring the heat production per se, but by measuring either the inputs or the outputs or both to that chemical reaction.